Hey class, this is the second example I'm going to run through of balancing a chemical equation. This time there's going to be a little difference here. The only difference is that we're working with a polyatomic ion now. Remember, a polyatomic ion, it's an ion that has a charge, but it's a group of atoms that make up the entire ion. So I'll tell you probably when we're working with polyatomic ions, and we'll go over now how they're different, but we should recognize that NO3, that quantity NO3, we should recognize that as a polyatomic ion. NO3 is nitrate, and we're going to see how we work with it when we balance our chemical equations. So again, we've got an unbalanced chemical equation here. We've got no subscripts. I'm going to split up my product side from my reactant side. I've got my reactants, and I've got my products. Get that in the frame. So, first things first, I need to tally up what I've got when I am unbalanced. So, I've got Hg, that is mercury. I've got Cl, that is chlorine. I've got Ag, that is silver. Then I've got NO3. So, how we work with polyatomic ions when we're balancing chemical equations, treat it as a single atom. So just like we have a mercury atom, we have a chlorine atom, we've got a silver atom. Let's say we've got a nitrate ion that we're going to balance. We can do this because it stays together in this group. We don't need to keep track of the nitrogens and the oxygens because they're going to travel together no matter what in this polyatomic ion form. In the previous one, we had the hydrogen would move back and forth between different molecules, but here this NO3 is going to stay together just like an atom would. And we can see that's true because we've got NO3 on this side as well. So that NO3, that nitrate, stays together. So we just got to keep track of that nitrate. And so we've got mercury, chlorine, silver, and nitrate. On this side, we've got mercury, chlorine, silver, and nitrate. It's a little bit rearranged, but we've got all of our pieces on both sides. So when we start to get our tally, Hg, Cl, Ag silver, and NO3 nitrate. So just like we have our atoms listed out, our other elements, we're going to list out nitrate as its own. I've got one atom of mercury when I'm unbalanced. I've got two atoms of chlorine when I'm unbalanced because I've got a subscript of 2 in front of my chlorine. I've got one atom of silver, and I've got one ion of nitrate. So when I'm unbalanced, I did the tally. I keep this NO3 together. I don't care about the nitrogen and the oxygen. I care about the nitrate ion as a whole. If I do the same thing on this side, write it out the same way. Mercury, chlorine, silver, and nitrate. I can see I've still got one mercury. And I'll go down the line. I've only got one chlorine here. I've got one silver. But then I've got 2 nitrates. So because we're treating this nitrate as a group, we've got to write these parentheses in here because that group contains, that it runs together as a group. So it's got to be multiplied as a group as well. So this NO3 quantity, my nitrate quantity, has a subscript below. This is NO3 in parentheses, and then there's a 2 on the outside right here. That's a 2 subscript outside my parentheses, which tells us that we've got 2 of everything inside the parentheses. We're working as NO3 as its own thing right now, So we're going to say we've got 2 nitrate ions. And now it's time to do a little bit of work. Now we've got to do the actual balancing. So we've got to figure out what we need to start with to balance. Our mercury quantities are the same, so we probably might not need to start there. Chlorine, we've got something different, and nitrate, we've got something different. So let's start off by balancing chlorine. So I've got 2 chlorine here. I need to get a second chlorine on this side. The only place chlorine shows up is in my silver chloride right here. So I'm going to add a 2 to my silver chloride. What that's going to do is that's going to increase my count for chlorine by 1. Now I've got 2 molecules of silver chloride. So I've got 2 chloride atoms. Each molecule has 1. I've got 2 molecules. So now I've got 2 chloride atoms. Same thing works with silver. Each molecule has 1 because there's no subscript. That's a G. That's Ag. That's not like a subscript for A. That's Ag for silver. There's no subscript, but I've got 2 of those molecules. So I've got 2 molecules of silver. I'm sorry, 2 atoms of silver. So I've balanced chlorine, but now I've unbalanced my silver by adding that subscript. When you add a subscript, it affects everything in that molecule. So now I've unbalanced my silver that was previously balanced. So I can go to this side and adjust that. I need to get my count for silver up to 2, so I'm going to add a 2 onto this side. So in my silver nitrate, I've got 1 atom of silver and 1 ion of nitrate. Remember, we're treating that nitrate as its own thing. So I can increase my silver count to 2. But I've also got to increase my nitrate count to 2 as well. I've got 1 atom of nitrate, 1 ion of nitrate, and I can tell that because there's no subscript outside of the parentheses right here. It would go right here. We're assuming it's a 1 because nothing is there. It would go right there just like this 2 is right here on this side. Because I have no subscript there, I know I just have 1, but now I've got 2 of this entire silver nitrate molecule. So I've got 2 ions of nitrate. And that actually helped us out because we were going to have to balance that nitrate out right here with on this side. So we can see, if we double check, we've got 1 atom of mercury that balances with my product side. My reactants have 2 atoms of chlorine that balances out with my 2 atoms of chlorine over here. I've got 2 atoms of silver that balances out with my 2 atoms of silver on this side, and my 2 ions of nitrate balance out with my 2 ions of nitrate here. So we can say we're check, 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 and we are all balanced. So what our chemical equation is now balanced. What this tells us that it takes 1 molecule of mercury chloride, and I guess that would be mercury 2 chloride. 1 molecule of mercury, 2 molecules of silver nitrate to react and get us 1 molecule of mercury nitrate and 2 molecules of silver chloride. So this is how the reaction actually functions in the real world. It takes 1 molecule of this, 2 molecules of this to get us 1 molecule of this and 2 molecules of this. And that's how you work with polyatomic ions. Just keep them together and keep track of them like you would any other atom, but keep track of them as a group.